Hello, hi everyone. Welcome to the next video of this series. In this video, we are going to discuss some previous year questions of liquid solutions and colligative properties. Okay, so let's proceed in a systematic manner. First, we are going to discuss weightage, then syllabus with the help of the mind map, and then we will solve previous year questions. Okay. Now, who will get benefit from this video? Who knows the basics but unable to solve the questions, unable to solve the JEE Mains questions, unable to solve the competitive questions, right? Who has the NCERT level knowledge? Student can solve the NCERT question but not the multiple choice questions, and has taken coaching somewhere but the problem solving skill is not clear. How to find out the information from the question, it is not clear. So this video is for those students. Okay. Now, how to use this video? You have to revise the short notes. I will be discussing some formulas, but you have to revise the entire chapter completely. Then you have to write down the important information and then you have to start doing the questions. Okay. Now, what is the weightage? So, weightage is around 6%. So, one question is going to come in sets, right? But in some sets we can have two questions also, right? So this topic is a important topic with respect to JEE Mains, and it's very easy topic. You can score full marks if the question is going to be from liquid solution. Okay, up now, what are the high priority topics? So generally the questions are going to be from colligative properties, right? Colligative properties, or we can say abnormal colligative properties, in which we have association and dissociation. So we have so many questions on the colligative properties and Raoult's law. That's it. So these two are very important topics if you don't want to do other topics. But all the topics are important, all the topics are very easy. So my advice is to do all the questions, all the topics in the liquid solution. Okay. Now let's discuss the mind map. So in liquid solution, first we have the concentration terms, and the concentration terms we have already discussed in stoichiometry part. Right. So I'm not going to repeat concentration terms question over here. Then we have the solubility. Solubility of gas in a liquid. We are going to apply the Henry's law, right? Then we have the liquid in liquid solution. Liquid in liquid solution. So what is the vapor pressure, right, of the volatile liquid, right? So we are going to use Raoult's law for that. So in the liquid solution, we are going to understand vapor pressure, and with respect to vapor pressure, we have the Raoult's law. Raoult's law we are going to apply in ideal solutions, non-ideal solution, and azeotrophs. Okay, is it clear? Next, we have the colligative properties. So what are colligative properties? Which are dependent on number of moles. Okay, so we have four colligative properties. First is RLVP, relative lowering of vapor pressure. Second, elevation in boiling point. Then we have depression in freezing point, and last but not least, osmotic pressure. Okay, so we have some questions on all these colligative properties. Then we have the abnormal colligative properties, and in the abnormal colligative properties, we are going to introduce Vant-hoff factors. So here we have two cases. Here we have two cases. One is a case of association and another case is the dissociation case. So we have to find out the I value for association if association is happening, and second we have to find out the value of Vant-hoff factor for the dissociation process. If we have some solute which can dissociate, if you add that solute in the solvent, right? So we have these topics. I have divided all the questions of liquid solutions in the 9 topics, right? So in the first topic, in the type 1 questions, or in the type 1 topic, we are going to discuss questions which is related to Henry's law. So Henry's law determines solubility, right? What? Solubility of gas in a liquid. Gas in a liquid. Okay, with respect to pressure. Okay, so we know that gases are highly compressible, gases are compressible. So if you apply more pressure on gas, so that is directly proportional to the solubility of gas. Solubility of gas. Now solubility of gas we are going to write in terms of mole fraction. In terms of mole fraction. Okay, so we can say partial pressure of gas, or the we have a gas, right? So the pressure applied onto the gas is directly proportional to the mole fraction of the gas. Now when we remove the proportionality constant, so we have to put constant, and that constant is Kh. Kh, that is the Henry's law constant. This is the Henry's law constant. It is dependent on temperature. It is different for different gases, right? So we have this thing. Clear? We have the curve. So we will discuss the curve while discussing the question. Now on the basis of this formula, let's discuss the question number 1. Question says, the oxygen dissolved in water exerts a partial pressure of 20 kilopascal in the vapor above water. So it means pressure, we can say that is equal to 20 kilopascal, or we can say 20 into 10 to the power 3 pascal, right? Now the molar solubility of oxygen in water is x into 10 to the power minus 5 mole per decimeter cube. It means we have to find out the molarity. We have to find out the molarity. Okay, so how to solve this question? Kh is given and density of water with dissolved oxygen it is given, that is 1 kilogram per decimeter cube, or we can say 1 gram per ml, right? Okay, so how to solve this question? So see, pressure of gas, it is equal to Kh into mole fraction of gas, right? Mole fraction of gas. Now we can find out mole fraction of gas how? Pressure of gas upon Kh. So pressure of gas it is equal to 20 kilopascal, and this is equal to 8 into 10 to the power 4 kilopascal, right? That is for O2 gas. So on solving, you get 2.5 into 10 to the power minus 4, right? That is the mole fraction. So what information we can get from this? We can get 2.5 into 10 to the power minus 4 moles of gas is present in 1 mole of solution. So if you see from this thing, so this is 2.5 into 10 to the power minus 4 moles, right? 2.5 into 10 to the power minus 4 moles. So moles of solvent, which is actually water, that is 1 minus 2.5 into 10 to the power minus 4, right? We can ignore moles of solute, so we can say moles of water is also 1. Understood or not? So it means we can say that कि 1 mole solution है, so we can write 1 mole of solvent. 1 mole of solvent. It means solution mole is equal to the moles of solvent. Understood? So if we have number of moles of water as 1, right? So mass of water, 1 mole water mass, that is equal to 18 gram, right? So 18 gram. Now we have what? Density of water is equal to mass of water upon volume of water. So volume of water, which is comparative to volume of solution, which is also equal to 18 ml, right or wrong? It is equal to 18 ml, right? Clear? Now how to solve this? We have to find out the molarity. So in order to find out molarity, molarity is number of moles of solute divided by volume of solution in liter. If it is in ml, so you have to multiply the numerator with 1000, right? So moles 2.5 into 10 to the power minus 4, volume of solution in ml, that is 18, so we are going to write into 1000, okay, into 1000. So on solving this, you get what? 1388 into 10 to the power minus 5, right? That is the mole per liter, or we can say mole per decimeter cube. So obviously we have to find out the value of x. So the value of x over here, it is equal to 1388. Is it clear? So in that way we can solve this question. Now let's do next question. Henry's constant for 4 gases alpha, beta, gamma and delta in water at 298 Kelvin is given below. Okay, fine. Density of water is given. So this table implies that alpha has the highest solubility at 308 alpha has the highest solubility in water at a given pressure. See, pressure, right? Pressure of gas is equal to kh into solubility, na, solubility in terms of mole fraction. So we can say that solubility is inversely proportional to kh value. Less kh value is going to have more solubility. So alpha का kh value is maximum. For alpha kh value is maximum from table. So it means alpha has the minimum solubility. Alpha has minimum solubility. So it means this statement is false. Okay. Now see the second statement. Solubility of gamma at 300 Kelvin is lower than at 298 Kelvin. Gamma at 308 Kelvin solubility is less than gamma at 298 Kelvin. This is true. Why? Solubility of gases decreases on increasing temperature. How to relate this thing? See, when gases dissolve in water, so gases are converted to liquid. So gases to liquid, it's a kind of exothermic process, right? So exothermic processes are more favorable at lower temperature, not at higher temperature, right? So that's why solubility of gases decreases on increasing temperature. So this is true, but not related to table. Because question says this table implies that, right? This is true, but it is not related to table, right? It is a different thing. It's a part of the exothermic and endothermic process. Okay. Now let's see option number 3. Option number 3 says the pressure of a 55.5 molar solution of gamma is 1 bar. So pressure is equal to kh x, right? So molality is given. Molality, it is 55.5. So 55.5 molar means 55.5 moles are present in 1 mole of solution, right? 1 mole of solution, na, 55 point, not 1 mole of solution. What I am writing, molality means 55.5 moles are present in 1 kg mass of solvent. So mass of solvent, it means mass of solvent which is water. It is equal to 1 kg, which is 1000 gram. Now number of moles of solvent, it is equal to 1000 upon 18, which is equal to 55.5 only. Okay. Now how to solve this? You have to find out pressure for which gas? Gamma. So gamma, it is 2 into 10 to the power minus 5. Okay. Gamma, it is equal to 2 into 10 to the power minus 5. So let's solve this. So this is 2 into 10 to the power minus 5. But in kilobar, we have to find in bar. So it means we write into 10 to the power 3 bar. Now mole fraction, moles of solute divided by total moles, which is 55.5. Okay. When you solve this, so you get answer equal to 1 into 10 to the power minus 2 bar. 1 into 10 to the power minus 2 bar, which is false. So this statement is also false. Now see, ऐसे तो पता हो जाना चाहिए, right? Now we can analyze, like fourth is going to be the answer, but let's solve it. The pressure of 55.5 molar solution of delta 0.5, right, is 250 bar. So let's solve this. So pressure is equal to khx. So kh is 0.5 into 10 to the power 3, and here again 55.5 upon 55.5 plus 55.5 bit. Right, on solving this you get exactly equal to 250 bar. That statement is true. Okay, so this is how we are going to do this question. Okay, now next type of question based on this thing. So we have for a solution of gases W, X, Y and Z in water. Okay, Henry's law constant, they are given. The correct plot for the given data is. So see, we know that pressure of gas, it is equal to kH x gas. But we have a plot with respect to mole fraction of water. So we know that mole fraction of gas plus mole fraction of water, it is equal to what? We have two components. So we can say mole fraction of gas, it is equal to 1 minus mole fraction of water. So let's put this thing. So pressure of gas is equal to kH 1 minus mole fraction of water. On solving this further, we get kH minus kH mole fraction of water. Bete. Clear? Now we are going to relate this equation with y is equal to mx plus c. So this is equal to yc plus mx. So from this, we can say slope is negative. So it means this is wrong because slope is negative, right? So the one which has more value of kh, that is going to have more slope, right? So it means kh high value, more slope, right? So now we have alpha, or sorry, w, x, y and z. So w kh is 0.5, x is 2, y 35 and z 40. So kh order is z greater than y then x and w. So slope of z should be more than y then x and then w. Okay. So w to 0.5 hai na, so slope is going to be nil, right? Nil. So if you see the graph carefully now, so you get option number 1 as the answer. Z1 is going to have higher slope, then we have y, then x and then w. Clear? Then w. Okay, so option number 1 is the correct answer. Now let's do next question. Next question. Which one of the following statements regarding Henry's law is not correct? So not correct. The first statement. Higher the value of kH at a given pressure, higher is the solubility. No, we have discussed, right? kH is inversely proportional to solubility. So beta, this is incorrect only. But let's check this statement too. Different gases have different kH value at the same temperature. Yeah, same temperature, different gases, they can have different value. Third, the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. No, no. Partial pressure of the gas in vapor phase, right? Vapor phase, yani in the gaseous state. So that is equal to the mole fraction of gas in the vapor phase into total pressure. Here we are going to apply Dalton's law of partial pressure. Dalton's law of partial pressure. This is incorrect. This is incorrect, but that is as per the Raoult's law, not with respect to Henry's law. This is incorrect, but from Raoult's law. Now next. The value of kH increases with increase of temperature and kH is a function of the nature of gas. This is true. kH value, it increases, right? So option 1 is going to be the correct answer. Okay. Now let's do next question. A 300 ml bottle of soft drink has 0.2 molar CO2 dissolved in it. Okay, fine. So volume is equal to 300 ml and 0.2 molar CO2. So assuming CO2 behaves as an ideal gas, the volume of the dissolved CO2 is STP. So it's simply a mole concept question, right? So first we are going to find out the number of moles of CO2. So how molarity is equal to number of moles of solute divided by volume. If it is in ml, so numerator may multiply by 1000. So this is 0.2 number of moles of CO2 into 1000 divided by 300 beta. So on solving this, what do we get? We get 0.2 into 3 upon 10. Okay, so we get number of moles equal to 0.06 mole. Okay, so it is given 1 mole of STP, 1 mole of gas at STP, it is equal to 22.7 liter. So 0.06 mole of gas at STP is equal to 0.06 into 22.7 liter, bache. Right, so on solving this, we get 1.362 liter. But we have to report the answer in terms of ml. So this is going to be 1362 ml. Okay, bete. So answer is 1362. Clear? Now we are moving to the next type of topic or next topic that is related to the vapor pressure, right? So vapor pressure of liquids basically, right? Liquids. So see, if we have a liquid and that liquid is volatile in nature, volatile, volatile liquid, it means can be converted into vapors, can be converted into vapors, right? So if that liquid is taken in a closed container, then what happens? Slowly, liquid particles, they are converted to vapors and then they can apply pressure. Okay. So pressure applied by vapors is equal to vapor pressure, right? Now suppose if you are heating this, so in a closed container, what happens? Boiling can start. So boiling, at boiling, or we can say, when can we say ki boiling start? When vapor pressure is equal to the atmospheric pressure. When vapor pressure is equal to the atmospheric pressure, then we can say boiling start. Okay. At sea level, at sea level, atmospheric pressure, atmospheric pressure is equal to 180. Okay, bete, it is equal to 180. So this is a theoretical part, right? So let's do some question on this. So question says, based on the given figure, the number of correct statement is R. So liquid molecules on the surface. So we have some liquid molecules on the surface. Okay, fine. And then we have some liquid molecules in the bulk. Fine. So question says, surface tension is the outcome of equal attractive and repulsive forces acting on the liquid molecule in bulk. Outcome of equal attractive? No. Basically, if I say ki what is surface tension, so suppose we have a liquid particle on the surface. Then what happens? We have more force like this, na? We have more of unbalanced force. We have more of unbalanced force. So this is called surface tension. It means liquid molecule particle cannot be on surface due to more pull from the bulk particles or from bulk liquid particles, right? So this is not the equal attractive and repulsive force. No, that is wrong. Now second statement, surface tension is due to uneven forces acting on the molecules present on the surface. This is true. This is true. Very true. C, the molecule in the bulk can never come to the liquid surface. No, it is not true. If it is true, if this statement is true, then we cannot have the concept of vapor pressure, right? So this is false. Next, the molecules on the surface are responsible for vapor pressure if the system is in a closed system, right? So if the system is closed, if the liquid is volatile, then what happens? Surface particles, they can be converted into vapors, and when they convert into the vapor form, then these vapors can apply pressure which is equal to vapor pressure. So this is true. So out of A, B, C, D, two statements are true, two statements are correct, B and D. So answer is 2. B and D are correct. Okay. Now let's do next question. Next question says the boiling point of C6H6. Okay. Methanol, C6H5NH2, aniline and nitrobenzene. 80 degree, 65 degree, 184 degree Celsius, 212 degree Celsius. Which will show highest vapor pressure at room temperature? So room temperature 25 degrees Celsius, right? So if the vapor pressure, is equal to the atmospheric pressure, then we can say boiling starts. Boiling starts. Okay. So अब see, if you see, lowest boiling point is of methanol. So it means methanol is going to have more vapor pressure at room temperature. Vapor pressure is inversely proportional to boiling point. If vapor pressure is more, then we have to provide less amount of heat energy in order to make vapor pressure equal to atmospheric pressure. Okay, so that's why we can say that this is the methanol. It means at room temperature we can have more vapor pressure of methanol in comparison to other, right? Because boiling point is 65 degrees Celsius. Okay, that's it. Now let's do next question. Two open beakers, one containing a solvent and other containing a mixture of that solvent with a non-volatile solute are together sealed in a container. Okay, so this is a sealed container. In this sealed container, we have two beakers, right? One beaker is this, another beaker is this, right? So in one beaker, in this beaker, what do we have? We have a solvent, pure solvent, pure solvent. We have what? Pure solvent. Now in this beaker, what do we have? We have non-volatile solute, non-volatile solute plus solvent. Okay, bachche. So what happens? In this, what happens? If we have the pure solvent, then it is converted to vapors, right? Right? It is converted to vapors, pure solvent. But here we have some non-volatile solute which is also on the surface. So here we have less vapor pressure. Here we have more vapor pressure, right? Vapor pressure is an equilibrium process. It is an equilibrium process. So what is going to happen over here? What is going to happen over here? Total volume of the solution increases. Total volume of the solution increases. Why? We can, because we have solvent, pure solvent, we can have solvent over here. Right, the total volume of solution increases, but volume of the pure solvent decreases. Why? Because this pure solvent is going to convert into vapors, or we can say in form of more vapors, and then here we have less vapors. So these vapors क्या हो जाएंगे? They are going to convert into this, right? They are going to convert into this B, or we can say pure vapor goes to B, right? So pure vapors from A goes to B in order to maintain the vapor pressure, in order to maintain the vapor pressure. So we can say the volume of solution increases and the volume of the solvent decreases. Volume of the pure solvent basically decreases, right? So these are some questions based on vapor pressure. That's it. Now we are moving to the next topic in which we discuss some question, that is the Raoult's law. So let me write some important formulas and then we will solve questions. So what is Raoult's law? So suppose we have two liquids, right? We have mixture of liquids. So this is A liquid and this black one, that is B liquid, right? So pressure of A in a mixture, it is equal to P naught A XA and PB is equal to P naught B XB. P naught A is equal to vapor pressure of pure solvent A. Pure solvent A. P naught B is equal to vapor pressure of pure solvent B. Okay. PA is equal to pressure of solvent A in a solution. PB is equal to pressure of solvent B in a solution. Now PT is equal to total PA plus PB, or we can say that P naught A XA plus P naught B XB. Okay. We also know that XA plus XB is equal to 1. So we can say XA is equal to 1 minus XB, or we can say XB is equal to 1 minus XA. ठीक है? So that is Raoult's law. So we have ideal solutions, right, which follow Raoult's law at all conditions, right? And what is Raoult's law? Pt is equal to P naught A XA plus P naught B XB, right? Okay. Then we have non-ideal solution. Non-ideal solution. The non-ideal solution where Pt is not equal to this. P naught A XA plus P naught B XB. Okay. Here XA and XB, these are the mole fractions in liquid state. In liquid state. Now, if I want to find out the vapor pressure, right? So here we can say that Pa is equal to Ya into P total, where Y is the mole fraction of A in vapor phase. Similarly, Pb is equal to Yb into P total. Okay. So what is Ya and Yb over here? Ya and Yb, mole fraction in vapor phase. In vapor phase. Okay. Now we are going to use these formulas to solve the question. So first question says the total pressure observed by mixing two liquids A and B is 350. So Pt is 350 mm of Hg. When their mole fractions are Xa is equal to 0.7 and Xp is equal to 0.3 beta. Okay. Now question says the total pressure becomes 410. Now P dash T becomes 410 if the mole fraction of A they are changed to 0.2 and B 0.8 respectively for A and B. So we have to find out the vapor pressure of P or A. We have to find out what? We have to find out P naught A. So see, we can form two equations based on Raoult's law. So here we can say Pt is equal to P naught A XA plus P naught B XB beta. So here we have 350, which is P naught A into 0.7 plus P naught B into 0.3. This is first equation. Okay, P naught B into 0.3. Similarly, we can write 410 is equal to P naught A 0.2 plus P naught B into 0.8. Now we have to find out P naught A. So we have to solve this. We have two variables and two equations, so we can easily solve this. So what we are going to do? We are going to multiply first equation with 8 and we are going to multiply second equation with 3. So that it becomes 2.4 P naught B and this also becomes 2.4 P naught B. Okay. So once you do so, you get first equation as 2800 5.6 P naught A plus 2.8 2.4 P naught B, and second as 1230, right, as 0.6 P naught A plus 2.4 P naught B. Now let's subtract. So we will cancel this thing and we get P naught A equal to 314 mm of Hg. Okay, that's it. So answer is what? 314. Okay. Now let's do next question. Next question says 1 mole of heptane, it was mixed with 4 moles of octane. So heptane I am writing as A and octane I am writing as B. So vapor pressure of heptane, it means P naught A, it is given 92 and P naught B, it is given 31. 1 mole of heptane, it means number of moles of A 1 mole and number of moles of B 4 mole. Mole fraction of A, it is number of moles of A divided by total moles, which is 1 upon 5. And mole fraction of B, it becomes 4 upon 5. Number of moles of B divided by total moles, right? So we have to find out vapor pressure of resulting ideal solution. It means we have to find out Pt beta. So now how to solve this? Pt is equal to P naught A XA plus P naught B XB. So we have all the values. Let's put it. P naught A is 92 into 1 upon 5, right? Right, 1 upon 5. And P naught B is 31 into 4 upon 5. Okay. So once you solve this, you get 43.2 mm of Hg. You get 43.2 mm of Hg. So the answer is option number C. Okay. Now let's do next question. At 363 Kelvin, the vapor pressure of A is 21 kilopascal and that of B is 18 kilopascal. 1 mole of A and 2 moles of B are mixed. Assuming that the solution is ideal, the vapor pressure of the mixture is. So we have to find out PT. So P naught A, it is given 21 kilopascal bete, and P naught B, it is given 18 kilopascal. 1 mole of A and 2 moles of B, they are mixed. So it means mole fraction is going to be 1 by 3 and mole fraction of B, it is going to be 2 by 3. Now how to solve PT? P naught A XA plus P naught B XB बच्चे. So this is 21 into 1 by 3 plus 18 into 2 by 3. So 7 plus 12, right? So 12 plus 7, that is going to be 19. So answer is 19 kilopascal. So answer is 19. Okay. Same thing. Now let's do next question. Next question says, at a given temperature, the total pressure and torr of a volatile component A and B is given this. And we have to find out P naught A and P naught B, right? We have to find out what? P naught A and P naught B. And P naught B. So let's find it out. See, this equation is given and we know that P total is what? P naught A XA plus P naught B XB. Now, if you see this equation carefully, we do not have XA. We do not have XA. So what I am going to do, in place of XA, I can write P naught A 1 minus XB. है ना? P naught B XB. Because XA plus XB, it is equal to 1. So we get P naught A minus P naught A XB plus P naught B XB. So this is P naught A and XB common, then we can say P naught B minus P naught A. Now we are going to compare this equation, which I am taking as 2, with the equation number 1. So let's compare equation number 2 with equation number 1. So we get P naught A is equal to 120, right? And P naught B minus P naught A as 75, right? P naught A and P naught B as 75, वो भी minus का 75. So let's do this part only. So P naught A bete, on comparing 1 and 2, P naught A is equal to 120 and P naught B minus P naught A, it is equal to minus 75. So P naught B is equal to minus 75 plus P naught A, which is minus 75 plus 120, which is equal to 45. So P naught A value is equal to 120 and P naught B value is equal to 45. So answer is going to be option number 3. Clear? Answer is going to be option number 3. Now let's do next question. Question says, at 300 Kelvin, the vapor pressure of a solution containing 1 mole of N-hexane, है ना? 1 mole. So I am taking hexane as A. So number of moles of A, it is equal to 1 mole. And then N-heptane. N-heptane I am taking as B. So number of moles of B, it is equal to 3 mole. So total pressure is 550 mm of Hg. Fine. A question says, if 1 more mole of N-heptane is added to the solution, so it means N-A is 1 mole only, but N-B is going to be 4 mole. Okay. Vapor pressure of the solution increases by 10 mm of Hg, यानी P dash T is equal to 10 mm of Hg. What is the vapor pressure of an heptane in its pure state? It means we have to find P naught B. Again, we have to make two equations, right? How? Here, XA is equal to 1 by 4 and here XB is equal to 3 by 4, number of moles of B divided by total moles. If you find this thing, so XA dash is equal to 1 by 5 and XB dash is equal to 4 by 5 beta. We have to form two equations, right? We have to form two equations. So first equation is going to be 550 P naught A into 1 by 4 plus P naught B into 3 by 4. If you write equation this, it is increases by 10 mole, na 10 millimole. It is increases by 10 millimole. So here it is 560. So here we write 560 is equal to P naught A into 1 by 5 beta and P naught B into 4 by 5. Now you have to solve equation 1 and 2, right? So on solving equation 1 and 2, P naught B, it is equal to 600 mm of Hg, right? 600 mm of Hg. Okay, that's it. Simple question, right? You have to do the calculation. Now, next question, that is in vapor. Mole fraction of A vapors above solution in mixture A and B, right, will be. It means you have to find out YA. XA is given 0.4. So, beta PA is equal to YA into P total as per Dalton's law of partial pressure. Partial pressure of gas is equal to mole fraction of gas into the total pressure. Now, YA I can write as PA upon P total. Okay. YA is equal to P naught AXA बच्चे upon P naught AXA plus P naught BXB. Okay. P naught AXA plus P naught BXB. Right. Up P naught AXA, P naught A it is given 100. So 100 into XA is 0.4. Then 100 into 0.4 plus P naught B XB. P naught B is 200. And mole fraction of B, if XA is 0.4, so we know that XA plus XB is equal to 1. So XB is equal to 1 minus 0.4 beta, it is equal to 0.6. Okay, so let's solve this. So when you solve this, you get 40. Here you get 40 plus कितना हो जाएगा 200 into 6, right? So 120. So we get 40 upon 160. So we get 1 by 4 as the answer and 1 by 4 is equal to 0.25. ठीक है? So answer is going to be option number C, 0.25. Clear? Now let's do next question. The vapor pressure of pure liquid A and B are given. It means P naught A it is given 400 mm of Hg and P naught B it is given 600 mm of Hg. Perfect. On mixing the two liquids, the sum of their initial volume is equal to the volume of the final mixture. Fine. It means volume of solution it is equal to VA plus VB. Right? It means they are ideal solution. So for ideal solution, delta V mixing is equal to 0 and delta H mixing is equal to 0. So if they are ideal solution, it means they follow Raoult's law, right? So if they follow Raoult's law, so we have to apply this PT is equal to P naught A XA plus P naught B XB, right? That's it. So question says the mole fraction of liquid B is 0.5 in the mixture. XB is equal to 0.5. So it means XA is equal to 0.5 beta, or we can say 1 by 2 or 1 by 2. Clear? The vapor pressure of the final solution, it means we have to find out total pressure and mole fraction of components A and B in vapor phase. We have to find out YA and YB. Right? So how to solve this? So P naught A is 400, XA is 1 by 2, P naught B is 600 and XB is 1 by 2. So we get 200 plus 300, which is equal to 500 mm of Hg. So it means option number 1 and 3, they are wrong. Now we have two options, option number 2 and 4. So let's find out Ya. So PA is equal to Ya into P total. So Ya is equal to PA upon P total. PA we can find out by P naught AXA upon P total. So P naught AXA is this, which is 200, and P total is 500, which is 2 by 5, and 2 by 5 is 0.4. So if Ya is 0.4, so Yb is equal to 0.6. Why? Because Ya plus Yb again 1. Okay. So it means we have option number 4 as the answer. We have option number 4 as the answer. Okay. Now let's solve next question. Next question says liquid M and liquid N forms an ideal solution. Okay. The vapor pressure of pure liquid M is 450 and P naught N it is equal to 700. Then correct statement is fine. So if you see the options, so we have XM, XN, YM and YN. Okay, so it means we are going to use this formula. What? PM is equal to YM into P total. Okay, bete. PM is equal to YM into P total and PN is equal to YM into YN into P total. Okay. So in place of P total, what we can write? PN upon YN. Okay. Up now we can say that PM is equal to YM, and in place of P total I can write PN upon YN. Okay. So we can write PM upon PN is equal to YM upon YN. PM upon PN we can write as P naught M XM upon P naught N XN, which is YM upon YN equal to this. Now let's put the value. So P naught M value is 450 and this is 750. So 450 upon 750. XM upon XN is equal to YM upon YN. Okay. So on solving this, what do we get? So we get 5 9s are 45. So 9 by 15 है ना? Yeah. So that is XM upon XN, which is equal to YM upon YN. So what we can write? What we can write from this? We can write XM upon XN is greater than YM upon YN. देखो see, YM upon YN, basically this YM upon YN, it is equal to 9 by 15 XM upon XN. So what we can write? We can write X upon M, it is greater than YM upon YN. So option 4 is the correct answer. Okay. Now let's do the next question. Next question says liquid A and B form an ideal solution in the entire composition range. Okay, fine. It means it follows Raoult's law. It follows Raoult's law. At 350 Kelvin, the vapor pressure of pure A and pure B, yani P naught A is 7 into 10 to the power 3 Pascal and P naught B is equal to 12 into 10 to the power 3 Pascal respectively. The composition of the vapor is in equilibrium with a solution containing 40 mole percent of A. It means XA is 0.4. So XB is equal to 0.6. Right? XB is equal to 0.6. So at this temperature, XA and XB ka value we have to find out. Right? So basically it says ki 40% and composition of the vapor phase is in equilibrium with the solution containing 40% of A. Right? Fine. Basically vapor phase mein we have to find out this Ya and Yb. But if you see the option na, here Ya and Yb they are going to be in terms of XA and XB. right? So let's suppose this is x dash a, this is x dash b, and here they have taken ya is equal to xa and yb is equal to xb. So we have to find this. How to find this? So bete ya is equal to pa upon p total बच्चे, right? pa p naught a xa x dash a and p total p naught a x dash a plus p naught b x dash b. Okay बच्चे, clear? So if you solve this, so p naught 7 into 10 to the power 3 Pascal into xa, it is 0.4 upon 7 into 10 to the power 3 into 0.4 plus 12 into 10 to the power 3 into 0.6. Okay bete, so 10 to the power 3, 10 to the power 3, 10 to the power 3, it is going to cancel out, and on solving you get 0.28. On solving this you get 0.28. ठीक है? So if xa is 0.28, so xb is 0.72. Why? Because xa plus xb, that is equal to 1. So xb is equal to 1 minus 0.28, which is equal to 0.7. Okay, clear? Now let's do next question. At 35 degrees Celsius, the vapor pressure of CS2 is 512 mm of Hg. Okay, vapor pressure of CS2, yani P naught A, it is 512 mm of Hg. And that of acetone, which is P naught B. Acetone ko I am taking B and CS2 ko I am taking A. Okay, bete? So that is equal to 344 mm of Hg. Solution of CS2 in acetone has a total vapor pressure of 600 mm of Hg. P total is 600 mm of Hg. That's a experimental. ठीक है? Okay. The false statement amongst the following is Raoult's law is not obeyed. So see what we are going to do now. What we are going to do, we have to assume over here कि suppose xa is half and xb is equal to half. Then only we can have the maximum pressure, right? We can have this pressure. So let's see this. So pt pt theoretical, it should be 512 into 1 by 2 bete plus 344 into 1 by 2. Okay, so when you solve this, so you get 2 to the 4, right? Then 5 6, and here you get 172. So on solving this, we'll get 428 mm of Hg, right? But the point is observed pressure observed is greater than total pressure, which is the theoretical pressure. See, theoretical pressure should be 428, but observed pressure is 600 mmHg. So if P total is greater than P naught A xa plus P naught B xb, then it means they are non-ideal solution which shows positive deviation from Raoult's law. Positive deviation from Raoult's law. So which shows positive deviation from Raoult's law. So their delta V mixing is greater than 0. Even delta H mixing is also greater than 0. Delta V mixing is greater than 0 and delta H mixing is also greater than 0. So now let's check this. Raoult's law is not obeyed by the system. That is true. We have to check false statement. Mixture of 100 ml of CS2 and 100 ml of acetone has a volume less than 200 ml. Nahi bhai. No. Their delta V mixing is greater than 0. So it should be greater than 200 ml. Okay. If we are taking 100 ml. So this is statement is wrong. CS2 and acetone, they are less attracted to each other. That's why their volume increases. Because they are less attracted to each other. Heat must be absorbed in order to produce a solution. So the point is that this is also true. Now why this is true? Heat must be absorbed in order to produce a solution at 35 degrees Celsius. The point is that which shows positive deviation, because attraction is less. Attraction is less in the final mixture. So if in the final mixture attraction is less, then we have to provide the energy in order to mix those two solvents, right? Are you getting this point? So it means that is also true. So option 2 is the incorrect one. Okay. That's it for the Raoult's law. Now we are moving to the next type of question, which is based on relative lowering of vapor pressure. So here we have the part of colligative properties. So colligative properties, they are dependent on number of moles of solute particles. So what happens when we add non-volatile solute in the mixture, in the solvent, not in the mixture? We can say what happens if we add non-volatile solute in the solvent. So vapor pressure decreases. Vapor pressure decreases. Why? Because those non-volatile solute particles, they are also present in the solution, like NaCl in water, that is present in the solution. So we have less volatile particles which are on the surface. If we have less volatile particles which are present on the surface, so what happens? Vapor pressure of the solution decreases, right? Because vapor pressure of the solution is due to the vapor pressure of solvent, pure solvent, because non-volatile solute is that solute which is not going to convert into the gaseous state. Understood? So let me write down some formulas related to this and then we will solve questions. So here let's say P naught is equal to vapor pressure of pure solvent, right? Vapor pressure of pure solvent, and PS is the vapor pressure of solution in which non-volatile solute is present, or we can say when non-volatile solute is present. Volatile solute is present. Okay. So if non-volatile solute does not dissociate or associate, then first of all that's not a condition abhi right now. So first of all, what is lowering in vapor pressure? So lowering in vapor pressure is P naught minus PS, right? And RLVP, relative lowering in vapor pressure, is P naught minus PS, or lowering in vapor pressure with respect to pure solvent, that is P naught, right? So when you solve this, you get here equal to, this is equal to XB, or where this is the mole fraction of solute. Mole fraction of solute. Okay. So this is RLVP formula. Above one is the lowering in vapor pressure. Up now, if solute is, or we can say if solute can dissociate or associate, then we have abnormal colligative property. So we have to introduce Vant-hoff factor for that. So we can say P naught minus PS upon P naught is equal to I into XP. Okay. Also, we have one more formula, P naught minus PS with respect to PS. It is equal to number of moles of solute upon number of moles of solvent. Okay, number of moles of solute divided by number of moles of solvent. Okay, now let's do question. So question 1 says 2 to 4 ml of SO2 at 298 Kelvin and 1 atm is passed through 100 ml of 0.1 molar NaOH solution. The non-volatile solute produced is dissolved in 36 gram of water. So the lowering of vapor pressure of solution is, it means we have to find P naught minus PS. Lowering. Assuming the solution is dilute, it means mole fraction of water is too much in comparison to mole fraction of solute, right? Not mole fraction, we can say number of moles of water is too much in comparison to number of moles of solute. P naught, it is given, that is 24 mm of Hg, right? And we have to find out lowering of vapor pressure, right? So let's do it. So we have SO2 plus NaOH, and it gives NaHSO3. Acha, we can do this question in two ways. We can also assume that SO2 plus NaOH gives Na2SO3, right? But if we assume this, if I'm going to assume that this is NaHSO3, if it forms NaHSO3, so it further dissociates into Na plus and HSO3 minus. And if I'm going to assume the complete dissociation, then Vant-hoff factor value is, we get 2 ions divided by total taken 1. So Vant-hoff factor is 2. Right. If you assume कि it forms Na2SO3, then it dissociates into 2Na plus and SO3 2 minus. So Vant-hoff factor is going to be 3 upon 1. Understood? So I am taking this. So SO2 plus NaOH, it gives NaHSO3. So what happens over here? So here we have 2 to 4 ml bete, temperature 298 Kelvin, pressure 180 atm. So we can use PV is equal to nRT, right? PV is equal to nRT to find out the number of moles. And NaOH moles, it is 0.1 molar and 100 ml. So millimole, molarity into volume ml. So which is 0.1 into 100 bete, which is equal to 10 millimole. Okay. Now let's find out moles of SO2. So moles of SO2, PV upon RT, pressure is 1, volume is 2 to 4, right? 2 to 4 ml. ठीक है? And R is 0.082 and temperature is 298 Kelvin. Right, so this is in ml, so let's convert this into liter, so 10 to the power minus 3. Okay, so on solving this, you get 9.16 millimole, or we can say 9.16 into 10 to the power minus 3 mole. Okay, up now if we see the reaction, so 1 mole of SO2 reacts with 1 mole of NaOH to give 1 mole of NaHSO3. Clear? So we have 10 millimole of NaOH and 9.16 into 10 to the power minus 3 millimole. 9.16 millimole of SO2. So obviously this is the limiting reagent and amount of product depends on limiting reagent. So here also we get 9.16 millimole. Okay. So NaHSO3 moles are also 9.16 millimole. Okay, bete. Up now we have to use this P naught minus PS upon P naught is equal to I into XB, mole fraction of solute. Why I? Because it can undergo dissociation. So P naught minus PS we have to find out. So this is I into P naught into XB. So let's solve this further. So P naught minus PS, I value is 2, P naught value is 24, it is given, right? And mole fraction of solute, number of moles of solute divided by number of moles of solute upon number of moles of solvent, right? Now number of moles of solvent 36, water hai. So number of moles of water, it is equal to 36 upon 18, which is 2 moles, which is equal to 2 moles, right? So what we are going to do, this is 2 into 24 into number of moles, 9.16 into 10 to the power minus 3, and we know that Na is too much in comparison to Nb, so we are going to ignore Nb from Na, and in the question it is given, so we write divided by 2. So on solving this, what do we get? We get 21.9 into 10 to the power minus 3, which we can minus 2, sorry, which we can write as 22 into 10 to the power minus 2. So x value is 22. Okay, so answer is 22. Now let's do next question. An open beaker of water is in equilibrium. Open beaker water है liquid, it is in equilibrium with H2O gas, is in a sealed container. When a few grams of glucose are added to the beaker, when a few grams of glucose they are added, right, to the beaker, the rate at which water molecules. So basically, if you add glucose into this, if you add glucose, so glucose is non-volatile solute. Non-volatile solute. So what happened? Vapor pressure decreases. Vapor pressure decreases. So it means the rate at which water molecule leaves the solution decreases. and vapor pressure is due to water only, right? Because water is the volatile. Water is volatile, it means it can be converted from liquid state to gaseous state. Okay, that's it. Now let's do next question. Next question says, at room temperature, a dilute solution of urea is prepared by dissolving 0.60 gram of urea in 360 gram of water. Fine. So number of moles of urea, given mass upon molar mass. So 0.60 and molar mass of urea is 60. Urea is this NH2, C double bond O NH2. So molar mass is 60. So here 0.60 upon 60, so we get 10 to the power minus 2 mole. Okay, bete. Now, number of moles of water, that is equal to 360 upon molar mass, which is 360 upon 80, 20 moles. Question, if the vapor pressure of pure water at this temperature is 35, yani P naught is 35 mmHg, then lowering of vapor pressure will be, lowering means P naught minus Ps, we have to find out. So which formula we are going to use, right? Which formula we are going to use? We are going to use P naught minus Ps upon P naught, and here we write mole fraction of urea. Acha, now the point is urea does not dissociate or associate. So here we are not going to introduce the Vant-hoff factor I. Okay, so let's put all the values. So P naught minus Ps is equal to P naught mole fraction of urea. So P naught mole fraction of urea is number of moles of urea divided by number of moles of urea plus number of moles of water, which is P naught is 35, number of moles of urea is 10 to the power minus 2 and water is 20. So on solving this further, we get 35 into 10 to the power minus 2 upon 20.02. Okay, and on solving this, we get 1.749 into 10 to the power minus 2, which we can write as 0.017, right? So answer is 3. Option 3 is the correct answer. Okay, now let's do the next question. A set of solution is prepared using 180 gram of water as a solvent. Okay, set of solution is prepared using 180 gram of water. 180 gram of water means number of moles of water is equal to 180 upon 18, which is equal to 10 mole. Okay, as a solvent. And 10 gram of different non-volatile solutes A, B and C. Okay, A, B and C. 10 gram, 10 gram, 10 gram. Right. So 10 gram is dissolved in 180 gram of water, right now? 10 gram is dissolved in 180 gram of water and this is the mass of solute. Find the relative lowering of vapor pressure in the presence of these solute. Relative lowering means P naught minus Ps upon P naught. We have to find out this value, which is equal to mole fraction. So it means we have to find out the mole fraction of solute. We have to find out what mole fraction of solute. So number of moles of solute, that is equal to 10 upon 100 because molar mass is 100, which is equal to 0.1. Then 10 upon 200, which is equal to 0.05, and then 10 upon 10,000, so which is equal to 0.001. Now mole fraction of solute we have to find out, which is equal to bete 0.1 upon 0.1 plus 10, है ना? Then 0.05 upon 0.05 plus 10. Then 0.001 upon 0.001 plus 10. Okay, bete? ठीक है? It's just we have to solve. So when we solve this, the mole fraction of this one A, it is going to be 9.9 into 10 to the power minus 3. It is going to be 4.9 into 10 to the power minus 3, and this value is 9.9 into 10 to the power minus 5. So which one has more mole fraction? Obviously A has more mole fraction then B, and then C. So option 3 is the correct answer. Okay, option 3 is the correct answer. Okay, now we are moving to the next type of the question. In this, we are going to discuss some question which is related to elevation and boiling point. So elevation and boiling point is observed. It is observed on addition of non-volatile solute. Why? Because when we add non-volatile solute, then vapor pressure decreases. And if vapor pressure decreases, then we have to heat more in order to make vapor pressure equal to atmospheric pressure. That's where there is the elevation in the boiling point. So let's write down some formulas. So here what we are going to say is suppose we have TB, and TB is what? Boiling point of solution, and T naught B is the boiling point of pure solvent. Okay. So elevation and boiling point, it is equal to TB minus T naught B, which is delta TB. Now delta TB is equal to KB into molality. Okay. What is KB? This is the molar elevation constant and ableuscopic constant. Okay. Ableuscopic constant. Okay. That's it. So we have to use this formula to solve question. Now how to calculate KB value? RTB square into molar mass, M is molar mass, upon 1000 into delta H vaporization. Okay. Also we can say this is going to be RTB square into molar mass, not molar mass, that is equal to 1000 into latent heat of vaporization, as latent heat of vaporization is equal to delta H vaporization upon molar mass. Okay. So these are the formulas that we are going to use over here. So let's do the question number 1. Question says a solution containing 2 gram of non-volatile solute. Okay. So mass of solute is 2 gram. In 20 gram of water, so mass of solvent, that is equal to 20 gram of water. Boils at this Kelvin, it means TB is equal to 373.52 Kelvin. Molecular mass of solute, it means molar mass of solute we have to identify. Okay. And T naught B, boiling point of pure solvent, it is given 373 Kelvin, and Kb value it is given 0.52 Kelvin kilogram per mole. Okay, so how to solve this? We have delta TB is equal to Kb into molality. So delta TB is TB minus T naught B, which is Kb into molality. Or in molality ko what we can write? Moles of solute divided by mass of solvent. If mass of solvent is in gram, then multiply the numerator with 1000. So TB minus T naught B, so 373.52 minus 373 is equal to 0.52 into moles of solute. Given mass of solute is 2 gram divided by molar mass of solute into mass of solvent 20 into 1000. So here we get 0.52, here we get 0.52 into 2 into 1000 upon molar mass into 20. On solving this, what do we get? We get molar mass equal to 100 gram. Okay, molar mass equal to 100 gram. So answer is 100. Okay, now let's do next question. Question says 1 gram of a non-volatile non-electrolyte solute. Non-electrolyte means cannot dissociate or associate, right? So 1 gram of a non-volatile, non-electrolyte solute is dissolved in 100 gram of two different solvents. ठीक है, solvent A and B. Fine. So if we talk about the molality, molality is what? Given mass divided by molar mass. Electrolyte is same. Electrolyte is same. So we can say that molar mass is same. Molar mass is same. Then mass of solvent is 100. If it is in 100, so we have to multiply this with 1000. It means we can say molality is same. Molality is same in different solvent A and B, right? So that is same. Abelioscopic constant are in the ratio 1:5. It means KBA is to KBB. It is equal to 1:5. And we have to find out delta TBA upon delta TBB. So which is equal to Kb into molality upon Kb into molality of A and molality of B. Okay, bete? So Ma is equal to Mb. So what we can write, what we can say, delta TBA upon delta TBB is equal to KBA upon KBB, which is 1:5. Right? Because molality is same. So rate of elevation in their boiling point, that is also going to be same. So option number 3 is the correct answer. Okay. Now let's move to the next topic. In this topic, we are going to discuss the freezing point depression. When there is the addition of non-volatile solute, as there is the elevation in the boiling point, there is a depression in the freezing point. Okay, so depression in the freezing point, what we can write? Delta TF. And delta TF depression, so we can say T naught F minus TF. ठीक है, that is the depression in the freezing point. So let me write down some formulas related to this topic and then we will solve questions. Okay, here T naught F is equal to freezing point of pure solvent. TF is the freezing point of solution. So depression in freezing point, delta TF is equal to T naught F minus TF, which is equal to KF into molality. Okay, KF is the cryoscopic constant. Okay, it's a cryoscopic constant. So we have one formula this. Now how to find out KF? That is equal to RTF square into molar mass upon 1000 into delta H fusion. Okay, so we have these two formulas. So let's solve the question 1. So question 1 says, in the depression of freezing point experiment, depression of freezing point, vapor pressure of the solution is less than that of pure solvent. This is true, right? This is true. So when you add non-volatile solute, so vapor pressure of the solution decreases, because now non-volatile solute also, they are also present in the solvent, right? So vapor pressure decreases. That's true. Vapor pressure of the solution is more than that of pure solvents. It contradicts first statement, so this is false. Now third, only solute molecules solidify at the freezing point. No, solvent molecules solidify at the freezing point. So this is true. So option number A and D, they are true. Hence option A is the correct answer. Okay. Now let's do the next question. Next question says 20% of acetic acid is dissociated. Oh, it is dissociated. It means here we have to use Vant-hoff factors. So delta TF is equal to I into KF into molality. Okay. So if dissociates, acetic acid is this. If it dissociates into CH3CO minus and H plus. So what we can say that ki, see, this is X and this is Y. So I is what? 1 plus alpha X plus Y minus 1. Right? I am going to prove it later, right? So here what we write? 1 plus alpha is 20%. Alpha is equal to 20%. It means 20 by 100, which is 0.2. So 1 plus 1 minus 1. So on solving this further, we get I ka value as 1.2. Okay. Up, it's 5 gram is added to 500 ml of water. So mass of water, it is 500 ml, and mass of solute, that is 5 gram. Molar mass of solute, which is acetic acid, it is equal to 60 gram. We have to find out the depression and freezing point. Okay, so delta TF is equal to I into KF into molality. So I value is equal to 1.2, KF value is equal to 1.86 beta, and molality is mass 5 upon 60, number of moles of solid 5 upon 60, volume of, sorry, mass of water 500, right? 500. So if mass of water is 500, so 500, oh, that's a volume of water is given na. So कोई बात नहीं, volume of water is equal to the mass, right? So mass of water is also 500 gram बच्चे, 500 gram. Why? Because density of water is 1, so mass of water is equal to volume of water. Okay, so we can write 500 and 500. So 500, and here we write 1000. Okay, so when you solve this, you get 0.372 is the answer. You have to report answer in terms of 10 to the power minus 3. So answer is going to be 372. Okay, 372 is going to be the answer. Now let's do the next question. Next question says a solution containing 62 gram ethylene glycol in 250 gram water. What is ethylene glycol? CH2OH and CH2OH. So this is 62 gram. Molar mass is 12 into 2 because 2 carbon atoms. Then 6 hydrogen, 6 into 1, and oxygen 2 into 16. So on solving that, we get 62 gram. So number of moles 62 upon 62, which is equal to 1 mole. Okay. Set 250 gram water, mass of solvent is 250 gram. It is cooled to minus 10 degrees Celsius. It means TF is minus 10 degrees Celsius and T naught F, that is 0 degrees Celsius. So we write delta TF is equal to KF into molality. So delta TF is T naught F minus TF, then KF into molality. So 0 minus minus 10, KF value is 1.86 and molality is 1 mole. Mass of water is 250 into 1000. This means 25 fours are 100, right? अच्छा यहाँ पे ना mass of water, just do not write mass of water. Let's find out the mass of water over here. Mass of water. ठीक है? So when we find out the mass of water from here na, so mass of water it comes out to be 186 gram. देख लो, let's solve it. See, this is 10, this is 1.86 into 1000. So upon mass of water, so mass of water is 186 gram. ठीक है? So it means rest of the water, it is converted or it is separated as ice. A question says the amount of water separated as ice. So total amount of water 250. So mass of water separated as ice is equal to total mass of water minus mass of water at minus 10 degrees Celsius. So on solving this, we get 250 minus 186, which is equal to kitna? 64 gram. So answer is option number 3. Okay. Now let's do the next question. So next question says elevation in the boiling point for 1 molar solution of glucose is 2 Kelvin. Okay. So delta TB is 2 Kelvin and depression and freezing point is also 2 Kelvin. Okay, fine. So delta TB is equal to delta TF. So we can say that KB into molality for this one is KF into molality for this one. So for boiling point, solution molality is 1. So we write KB into 1 and for Kf solution molality is 2. So 2. So Kb is 2 times of Kf. Very simple question, right? So this is option number 4, right? Option number 4 is the correct answer. Now let's do the next question. So next question says freezing point of a diluted milk sample is found to be minus zero point 0.2 degrees Celsius, while it should have been minus 0.5 degrees Celsius for pure milk. ठीक है? So it means TF pure milk divided by TF of diluted milk, right? T naught F is same, so we are writing TF only. KF is going to be same, so we can say molality of pure milk upon molality of diluted milk. See, delta TF is equal to KF into molality. So this is T naught F minus TF. It is KF into molality. So T naught F is going to be same, right? KF is going to be same, so we can cancel out. So that is basically minus 0.5 upon minus 0.2, and molality of pure milk. Number of moles, they are also constant. Number of moles of milk, that is also constant, na? So it means number of moles divided by mass of pure milk, then number of moles into mass of diluted. So from this we can say that W diluted upon W milk is equal to 5 over 2. 5 over 2, right? Diluted is equal to 5 over 2. So how to solve this? So we should now see the option. 1 cup of water or 2 cups of pure milk. Yani 2 cups of pure milk, but diluted one is going to have 1 plus 2, that is 3. Right? Now 2 cups of pure milk, so milk is 2, but the diluted one is going to be 3 plus 2, 5. So this is going to be the answer. In the third one, we have 3 cups of milk, but the diluted one is going to be 1 plus 3, 4. Here, 3 cups of pure milk, but the diluted one, it is going to be 2 plus 3, get 5. We should be getting 5 by 2. So it means option number 2 is the correct answer. Option 2, correct. Which one? 3 cups of water, 3 cups of water and 2 cups of milk. So milk 2 here. 3 cups of water, when you add 3 cups of water to 2 cups milk, so mass of diluted milk, it becomes 3 plus 2, which is equal to 5. Okay. Now let's do next question. C6H6 freezes at 5.5 degrees Celsius. So, okay, the temperature at which a solution of 10 gram this. Okay, it means this is the solvent. So T naught F is 5.5 degrees Celsius. So temperature at which a solution freeze na, so T we have to find out, and mass of C4H10, it is 10 gram. Molar mass of C4H10, it is 4 into 12 plus 10 into 1, which is equal to 58 gram. Okay, and mass of benzene, which is solvent, it is 200 gram. So let's solve this. Kf value is given. So delta Tf is equal to Kf into molality, that is T naught F minus Tf is equal to Kf into molality. T naught F, it is 5.5 minus Tf. Kf value is 5.12. 5.12. So 5.12, and molality, number of moles of solute, it is equal to 10 upon 58. So 10 upon 58, and solvent mass is 200 into 1000, because we have to find this in kg. ठीक है बेटे? So when you solve this ना, तो you get 5.5 minus TF is equal to 4.41. So TF is equal to 5.5 minus 4.41, which is equal to 1.09 degrees Celsius, equivalent to 1 degree Celsius. Okay, that's it. So here answer is 1. Okay, now let's do next question. So next question says freezing point of a 4% aqueous solution of X is equal to freezing point of 12% aqueous solution of Y. It means TF of X is equal to TF of Y. ठीक है? Okay, T naught F is same. T naught F is same. So we can say that TF is going to be KF. KF is also same, right? So KF we can cancel out. T naught F same, right? So delta TF is going to be same. KF it is same. So it means we can say that molality of X is equal to molality of Y. Right, so delta TFX is equal to delta TFY. It means molality of X is molality of Y. So let's solve this. 4% aqueous solution of X. It is 4% and this is 12%. So 4% means 4 gram in 100 gram of solution. Here 12 gram of solute in 100 gram of solution. So it means molality, we have to find out molality. It means 4 gram divided by molar mass of A, capital Ma, into mass of solvent. So mass of solvent is 100 minus 4, right? Mass of solvent is 100 minus 4. It is in gram, so multiply this with 1000. Then we have 12%, so 12 upon molar mass of B into 100 minus 12, that is the mass of solvent into 1000 बेटे. ठीक है, तो just solve this. तो when you solve this you get 4 Ma into 96, which is 12 upon Mb into 88, and we have to find out molar mass of Y, है ना? We have to find out molar mass of Y, and molar mass of A is X is given A. X is given A, so this is X and this is Y. So 4 upon 96A is equal to 12 My into 88. So My is equal to 12 into 96A upon 4 into 88. So on solving this, we get around 3.27A, which we can write as 3A. Okay, because in the options we have this 3A. 1 is equal to 3A. Clear? That's it. Okay, now we are moving to the next topic, and in this we are going to discuss some questions related to osmotic pressure. So first of all, what is osmosis? What is osmosis? Osmosis is flow of solvent from higher concentration to lower concentration. It means flow of solvent from solvent side to solution. Okay, so what is osmotic pressure? If I want to stop this flow, so that is pi. This is osmotic pressure, and how can we determine? CRT, where C is the molarity. Molarity, it means moles per liter. Okay, so we have to use this formula. Now let's use this formula in order to solve the question. So first question says the osmotic pressure. Here one more thing, slope is given. Slope ka value is 6 into 10 to the power minus 4. It is given in the question. So the point is the osmotic pressure of solution of PVC in this, they are plotted like this. So we know that pi is equal to CRT. Okay, so pi and C ko we can write that given mass upon molar mass into volume into R into T. So if you see this, the unit is gram per liter. It means mass per unit volume, not number of moles per unit volume. So here we can say W by V and RT upon M. Okay, bete. So we are going to compare this equation as y is equal to mx plus c. So intercept is 0, but m is equal to RT upon M, slope value. So RT upon M is equal to 6 into 10 to the power minus 4. Now let's put the value of RT in order to find out the molar mass. So R is 0.083 and temperature is 300. So 0.083, temperature is 300 upon molar mass, which is 6 into 10 to the power minus 4. So molar mass is equal to 0.083 into 300 upon 6 into 10 to the power minus 4. So on solving that, we get 4.15 into 10 to the power 4, which we can write as 41500 gram. Okay. So PVC mass is 41500 gram. And what is PVC? It's a polymer. So mass should be high, right? Mass should be high because it's a polymer, right? Now let's do the next question. So next question is theoretical question. Osmosis. What is osmosis? Solvent molecule flow from solvent side to solution side. So solvent molecules pass through semi-permeable membrane towards solution side. This is true. A can be matched with the option number third. So we have only two options with respect to that, second and third. So let's find out the difference, right? So C is different. Now let's find out what is C. Electroosmosis. So osmosis, dispersion medium, it means solvent like particles moves in an electric field. Right, so C can be matched with fourth option, right? C can be matched with fourth option. What is reverse osmosis? Solvent molecules pass through semi-permeable membrane towards solvent side, right? Solvent to solution is osmosis. Reverse, opposite to osmosis. So it means B can be matched with first and D can be matched with second. So option 2 is the correct option. This is completely a theoretical question, right? Easy question. Now let's do next question. Next question says at 27 degrees Celsius, a solution containing 2.5 gram of solute in 250 ml of solution exerts an osmotic pressure of 400 Pascal. So the molar mass of solute is, we have to find out molar mass of solute is. So see, R value it is given in bar, right? So 1 atm is equivalent to 1 bar and 1 atm is equal to 10 to the power 5 Pascal. So 1 Pascal is equal to 10 to the power minus 5 atm, and in question we have 400 Pascal. So 400 Pascal is equal to 400 into 10 to the power minus 5 atm. So pi is equal to C into R into T. In place of pi, we are going to write 4 into 10 to the power minus 5. Concentration. Number of moles of solute, which is given mass of solute 2.5 divided by molar mass. Volume of solution is 250, but that is in ml. So we have to multiply the numerator with 1000. R value is 0.083 and temperature is 27, which we have to convert into Kelvin, which is 300 Kelvin, right? Up now it's just we have to find out M value na. So on solving this, we get molar mass equal to 0.6225 into 10 to the power 5, which we can write as 62250 gram. Understood? So answer is this. Easy, based on formula, right? Now let's do next question. Next question says a solution is prepared by dissolving 0.6 gram of urea and 1.8 gram of glucose in 100 ml of water. The osmotic pressure of solution is. So first of all, we have to find out the concentration of mixture, right? Because pi is equal to C into R into T. So we have urea and we have glucose. This is 0.6 gram and this is 1.8 gram. Molar mass of urea is 60 gram molar mass and molar mass of glucose is 180 gram. So number of moles of urea is 0.6 upon 60, right, which is equal to 10 to the power minus 2, and this is 1.8 upon 180, which is 10 to the power minus 2. So total moles 2 into 10 to the power minus 2, right? That's it. Now let's solve. Pi is equal to C. C total moles 2 into 10 to the power minus 2 upon volume 100 ml into 1000. R value it is given 0.08206 and temperature is 300 Kelvin. So just solve this. 0.08206 into 300 Kelvin. So when you solve this, you get 492.36, which we can write as 492.36 divided by 100, right? Okay. So we can say this is 4.9280. Okay, clear. That's it. Okay, bete. Answer is option number 3. Okay. Okay. Finally, we are moving to the second last abnormal colligative property, which is also the last topic, because in the last time we are going to discuss some miscellaneous question in which we are going to use more than one concept to solve the question. So let's do abnormal colligative properties. So what happens in abnormal colligative properties? We have the non-volatile solute. We have the non-volatile solute which can undergo association or dissociation. Okay. So we have to introduce Vant-hoff factor, which is I. So I is actual, observed, experimental, colligative property divided by theoretical colligative property. Okay. So I value is greater than 1 for dissociation. Okay. And it is less than 1 for association. So for dissociation, alpha is the degree of dissociation, and if we have ax and by, so how to determine I value? 1 plus alpha x plus y minus 1. Okay, that's how we can determine. Now for association, beta is the degree of association. I am taking beta as the degree of association. So I is equal to 1 minus beta plus beta by n. N is equal to 2 if we have the dimer formation, right? Now, due to this, we have abnormal colligative properties. So in abnormal colligative properties, RLVP, it is going to be P naught minus PS upon P naught, which is I into mole fraction of solute. Or we can say P naught minus PS with respect to PS is equal to I into number of moles of solute upon number of moles of solvent. Then we have delta TF is equal to I into KF into molality. Then we have delta TB is equal to I into KB into molality. And then we have pi is equal to I into C into R into T. Okay, that's it. Now let's apply and solve questions. So question for number 1, the number of pairs of the solution having the same value of the osmotic pressure. Assume 100% ionization. It means we have to take care of the ion. So pi is equal to I into C into R into T. So R and T, they are same. So it means pi is equal to I and C. Right. So for option number A, we have 0.5 C2H5OH molar and 0.25 molar KBr. Now KBr dissociates into K plus and Br minus. So I value is 2 upon 1 because we have two ions and KBr 1. So 2 by 1, so I value is 2. Okay, bete. So here no dissociation, बच्चे. So here I into C is equal to 0.5 and here also I into C is equal to 2 into 0.25 which is equal to 0.5. So it has same. So A ka we have same. Now let's check for B. B K4FeCN whole 6. So it dissociate into 4K plus and FeCN whole 6 4 minus. Okay. Now FeSO4 NH4 2 SO4. So it dissociates into 2 ammonium, 1 Fe2 plus and 2 SO4 2 minus. So total 5 and here total 5. So here I ka value 5 upon 1 and here I ka value is also 5 upon 1. Concentration, they are same, 0.1 and 0.1. So concentration are same. So what we can do? Same value of osmotic pressure. We can say same value of osmotic pressure. Now let's check for C1. C. So C is 0.05 molar K4FeCN6. K4FeCN whole 6. I का value is 5. Now next 0.25 molar NaCl. 0.25 molar NaCl. So here I का value is 2. So pi cannot be same. Right? IC value cannot be same. So no. Now CD 0.15 molar NaCl and 0.1 molar BaCl2. 0.15 molar NaCl. I value is 2 for that. Na plus and Cl minus. So it gives 2 ions. So 2. So I into C is equal to 2 into 0.15 बच्चे. ठीक है? Which is equal to 0.3. Then we have 0.1 into BaCl2. 0.1 molar BaCl2. So here I का value 3. Why? Because BaCl2 dissociates into Ba2 plus and wait, and 2Cl minus. So here what happens? I का value is 3 and I into C, it is 3 into 0.1 which is 0.3. So for this we can have the same. So A, B, D same. Now let's check for E1. So let's check E over here only. So here we have K plus Mg2 plus 3Cl minus. So I ka value 5 and here I ka value is 2. Concentration, they are different. So for this one we can say IC is equal to 0.02 into 5 which is equal to 0.1 and here for KCl IC value is equal to 0.05 into 2 which is also 0.1. So answer is A, B, D and D. So total 4 pairs. Okay, so answer is 4. Now let's do this question. Question says solid lead nitrate is dissolved in 1 liter of water. So we have solid lead nitrate. Okay, it is dissolved in 1 liter of water. Volume is 1 liter. The solution was found to boil at this. Okay, so TB value is given 100.15 degrees Celsius. T naught B, we know that 100 degrees Celsius. So delta TB is equal to 0.15 degrees Celsius. Okay, बेटे. ठीक है. So what we can find out from this? We can find out molality, concentration. So delta TB is equal to I into KB into M. So I for this, if we assume 100% ionization, so that is going to be 3. Why? Pb2 plus and 2NO3 minus. ठीक है बेटे? 2NO3 minus. So we can write delta TB is 0.15. This is 3. KB value is 0.5 बचे and molality. So this is 0.15 upon 1.5. It is molality and molality is equal to 0.1. It means 0.1 mole of lead nitrate is present, right? So lead nitrate, we can say 0.1 mole, right? In, acha, molality and molarity is same in all cases. So 0.1 mole in 1 liter or 1 kg, right? We can assume this. So if lead nitrate is 0.1 mole, right? Lead nitrate is 0.1 mole. So Pb2 plus is 0.1 mole and NO3 minus that is equal to 2 into 0.1 which is equal to 0.2 beta. Okay. Okay. Now what happens? Now we have when 0.2 mole of NaCl is added to the resulting solution. So when 0.2 mole of NaCl is added, it means we have Pb2 plus and 2NO3. Let me write in that way. And when we write 0.2 mole of NaCl is added. So if lead nitrate we have 0.1, this is 0.2 and here 0.2. So what do we have? We have PbCl2 double displacement reaction, or we can say precipitation reaction, and then we have NaNO3. Okay, NaNO3. So now what happens? What happens over here? Okay, what we are going to do? So see, here we say this is 0.2, this is 0.2, right? Concentration. Up now for lead chloride, how to find out? For lead chloride, how to find out? So see, we have Pb2 plus and 2Cl minus and it will form PbCl2. So Pb2 plus is 0.1, Cl minus is 0.2. This is 0 pair. So after T, we have 0.1 minus x and this is 0.2 minus 2x. Clear? 0.2 minus 2x. Up now, total moles, if I want to find out total moles. So it is 0.1 minus x plus 0.2 minus 2x plus NaNO3 also, right? 0.2 plus 0.2. Okay? So when you solve this, you get some value. So it is going to be 0.3, 0.5, 0.7, 0.7 minus 3x. Okay, bete? Now what we are going to do? Now we are going to put this in. Acha. It was observed that the solution froze at itna minus 0.8 degrees Celsius. So it means delta TF value is 0.8. So if delta TF value is 0.8, so what we can write? Delta TF is equal to KF into molality. Molarity, they are all same. 1 kg, 1 liter, right? So let us take the moles only. So delta TF is 0.8. KF value is bete 0.18, right? It's 1.8, right? So 1.8 and here we write 0.7 minus 3x. So from here we can find out the value of x, which comes out to be 0.085. 0.085. Now what do we need to do? We need to find out the solubility product of PbCl2. So solubility product of PbCl2, it dissociates into Pb2 plus and 2Cl minus, right? So we have to find out concentration of Pb2 plus na. So concentration of Pb2 plus is 0.21 minus x. So concentration of Pb2 plus is 0.1 minus x, which is 0.1 minus 0.085, which is equal to 0.0148. Okay? Now concentration of Cl minus is going to be 0.2 minus 2x, which is 0.03. Now KSP, how to solve? That is KSP, concentration of this 0.0148 into 0.03 square. So on solving this, what do you get? You get 1.332 into 10 to the power minus 5. But we have to report the answer in terms of 6, 10 to the power minus 6. So we write 13.32 into 10 to the power minus 6. So the answer is equal to 30. Okay, understood, clear. In that way, we are going to find out the value for KSV. Okay. Now let's do next question. We have lead storage battery, right, which contain 38% by weight. It means 38 gram of H2SO4. So 38 gram, right, solute, and solvent is going to be the 62 gram. Now number of moles of solute, 38 upon 98 H2SO4. Okay. So Vant-hoff factor is also given 2.67. The temperature in Kelvin in which the solution in the battery will freeze. So we write delta TF is equal to I into KF into molality. So I is 2.67, KF is 1.8, molality is number of moles of solute, then mass of solvent, that is 38 into 1000. Okay, bete. So we can find out the value of delta TF over here. So delta TF comes out to be minus 30.05 degrees Celsius. Now that is T naught F minus TF is equal to minus 30.05, right? 05. So TF is equal to 0. एक मिनट, लेट मी टेम्परेचर इन केल्विन ना, ठीक है, तो 0 माइनस माइनस 30.05 विच इज 30.05, राइट. एक मिनट, जस्ट गिव मी अ मोमेंट. ओके, इधर do not write this thing, because we have already solved this thing now. Because see, here this comes out to be 30.05 degrees Celsius. So we can say that T naught F minus TF is equal to 30.05 degrees Celsius. So from that TF is equal to minus 30.05 degrees Celsius. Why? Because T naught F is 0 degrees Celsius. Okay. And now we have to convert this into Kelvin. So TF in Kelvin is equal to minus 30.05 beta plus 273.15, which is equal to 243.1 Kelvin. So you have to report your answer in form of 243. Okay, so just report the answer in terms of 243. Now let's do next question. A solute dimerize in water. So if it dimerize in water, so N ka value is 2. The boiling point of 2 molar solution, molality is 2 molar, it means 2 mole per kg of A. Boiling point is this 100.52 degrees Celsius. So percentage of association you have to find, beta you have to find out, and T naught B is equal to 100 degrees Celsius. Okay, so let's find out. So delta TB is equal to I into KB into M beta. Delta TB is going to be what? 100.52 minus 100. I ka value you have to find out, KB 0.52, and molality is 2. So we get 0.52 is equal to I into 0.52 into 2. So I value is 1 by 2. Okay. Up now we are going to use I is equal to 1 minus beta plus beta by n. N value is 2, so 1 by 2, 1 minus beta plus beta by 2. So when you solve this, you get beta value equal to 1. If beta value equal to 1, then what happened? 100% association, right? 100% association. So we have to report percentage association of A. So percentage association of A, it is going to be 100. Okay. Now let's do next question. So next question says, if a compound AB dissociates to the extent of 75% in aqueous solution, 75%, it means alpha is 0.75, X value is 1, Y value is 1, because we have to compare this with AX, BY. Okay. The molality of the solution which shows a 2.5 Kelvin rise. So it means delta TB is 2.5 Kelvin. And we have to find out molality. So how to find out? Delta TB is equal to I into KB into M beta. I, how to find? 1 plus alpha X plus Y minus 1. So 1 plus 0.75, 1 plus 1 minus 1. So we get 1.75. So I is 1.75, KB is 0.52, molality we have to find, and here we have 2.5. Either we can 2.5 Kelvin rise, or we can say 2.5 degrees Celsius rise. That is going to be same. because we are finding out the difference, right? We are finding out the difference. So when you solve this, so molality, when you solve this, so you get molality equal to 2.74 molar. And when you report, when you want to report the answer in the nearest integer, so this is going to be 3 molar. Okay. Now let's do next question. Next question says AB2 is 10% dissociated in water. 10% dissociate. It means alpha is 10 by 100, which is equal to 0.1 beta. The boiling point of 10 molar lactose solution, the molality is 10 molar, right? X का value is 1, Y का value is 2. So you can find I as 1 plus alpha X plus Y minus 1. ठीक है बेटे? And then what you need to do? You have to find out the boiling point. You have to find out TB. Very easy. You have to use this formula. Delta TB is equal to I into KB into M. And when you solve this, you get I, मतलब that TB का value, right? That TB का value is 106 degrees Celsius. So solve on your own. That's a simple question, right? Okay, that's it. Okay, now let's do this question. Question says a 1 molar K4 FeCN6 solution has a degree of dissociation 0.4. ठीक है, we have K4 FeCN whole 6 and this is 1 molar and degree of dissociation is 0.4. Its boiling point is equal to another solution. Okay, suppose it's TB1 equal to another solution which contains 18.1 weight% of non-electrolyte solute. So here we have non-electrolyte solute A. We have to find out molar mass of A. So here given mass of A is 18.1 gram. We have to find out molar mass of A, right? We have to find out what? Molar mass of A. Okay. Then if 18.1% है, so given mass of A. So solvent mass is 100 minus 18.1, which is equal to 81.9 gram. Okay. Now here we have TB2. अब question say boiling point is equal, right? So basically TB1 is equal to TB2. So here we write I into KB into M and here we write just KB into M. अब now first task to find out value of I. So I का value how to find out 0.4 है, ठीक है? So if I'm going to compare this with AX BY, तो X का value is 4 while Y का value is 1, ठीक है? So I is going to be 1 plus alpha is 0.4, then 4 plus 1 minus 1. So this is equal to 1 plus 1.6, that is equal to 2.6. Okay, bete. Now 2.6 into KB into molality. Molality it is given, that is 1 molar, ठीक है? And KB and here molality is 18.1 upon molar mass of A into 81.9. It is in gram, so multiply the numerator with 1000. Okay, bache. Now KB cancel out and now we can find out MA. So when you solve this completely, you get answer equal to 85 gram. You get answer equal to what? 85 gram. Okay. Now let's do next question. Next question says 2 molar solution of a weak acid HA has a freezing point of this. The degree of dissociation of this acid is. So you have to find out the value of alpha. So how to find out bete? So HA hai, degree of dissociation you have to find out. So first you have to find out the value of I, right? So delta TF is equal to I into KF into molality. Okay. So delta freezing point is this, right? So we can say T naught F minus ठीक है TF is equal to I into KF into molality. ठीक है बेटे, clear? Okay. So now when you solve this completely, so what do you get? So freezing point is this much, na, 3.885 and all. So let's write over here 3.885, right, is equal to I. Kf value it is given, that is 1.85, and molality it is given 2 molar. So you can solve I. So 3.885 upon 1.85 into 2. ठीक है, 1.85 into 2. Okay बेटे. अब now how to solve this? I का value it comes out to be 1.05. अब HA, for HA x is equal to 1, y is equal to 1. Compare this with AX, BY. So I is equal to 1 plus alpha x plus y minus 1. So I is equal to 1 plus alpha 1 plus 1 minus 1. So this is 1.05, that is 1 plus alpha. So alpha ka value is 0.05, which is equal to how much percent? 50 at 50 into 10 to the power minus 3, right? So 50 into 10 to the power minus 3. So we have to write the answer in terms of this only. Okay, in terms of this only. So that is going to be the answer. Now let's do the next question. So next question says when 9.45 gram of ClCH2COOH, basically ClCH2COO minus, and it gives H plus. It is going to dissociate in that way. So we have 9.45 gram. Now molar mass. So when you find out the molar mass of this, chlorine is 35.5, and when you solve this, so this is 94.5 gram. ठीक है. So number of moles of solute, it is equal to 9.45 upon 94.5. ठीक है बेटे, 94.5. And volume of water is 500 ml. So as density is equal to 1 gram per ml, so mass of water is also 500 gram. Okay, mass of water is also 500 gram. Freezing point drops by 0.5. So delta TF is equal to 0.5 degrees Celsius. So now how to solve this? Delta TF is equal to I into KF into molality. So we can find out the value of I. So that is 0.5 upon, ठीक है, KF value is 1.86. 1.86 and molality 9.45 upon 94.5, then mass of solvent 500, and here we write 1000. ठीक है. So when you solve this, you get I का value is 1.34. ठीक है, you get I का value is 1.34. So when you get I का value is 1.34, so you can find out alpha. I is equal to 1 plus alpha x plus y minus 1. So here I का value is 1.34 is equal to 1 plus alpha 1 plus 1 minus 1. So we get alpha is equal to 0.34. Now dissociation constant, how to find out? C alpha square 1 minus alpha. So it means C, what is the concentration? Concentration, if I want to find out the concentration. So concentration in terms of molarity we take, that is going to be number of moles of solute 9.45 upon 94.5, volume 500 into 1000. So when you solve this, you get 0.2 molar. So here we write 0.2 into 0.34 square upon 1 minus 0.34. So when you solve this, you get 35 into 10 to the power minus 3. Okay, 35 into 10 to the power minus 3. So we have to report answer in terms of this. So x ka value is going to be 35. Okay. Now let's do next question. K2HgI4 is 40% ionized. So K2HgI4, it dissociates into 2K plus and HgI4 2 minus बच्चे. 40% ionized means alpha is 40 by 100. So value of Vant-hoff factor है ना. So x का value is 2, y का value is 1. तो y is equal to 1 plus alpha x plus y minus 1. Just you have to solve, and when you solve, you get I equal to 1.8. Option number 2 is the correct answer. Okay, just try at home. Now Next, when 12.2 gram of benzoic acid is dissolved in 100 gram of water. So see, benzoic acid molar mass is 122 gram. ठीक है. So when 12.2 gram of benzoic acid is dissolved in 100 gram of water, the freezing point of solution was found to be itna. Okay, so delta TF is equal to 0.93, which is equal to I into KF into molality. So first you are going to find out the value of I. Everything is given. Molality, how to find out molality? Molality is number of moles 12.2 upon 122 into mass of solvent, which is 100 into 1000, right? So you can find out the value of I from here. So when you do so, I ka value comes out to be 1 by 2. Ab now this is the case of association. So I is equal to 1 minus beta plus beta by n, right? Okay, is it clear? So this is going to be what? 1 minus beta upon beta by n. So now you can find out the value of n. So n ka value comes out to be 2. Okay, n ka value comes out to be 2. That's it. That's the case. Okay. Next question. Molecules of benzoic acid dimerize in benzene. Dimerize in benzene means n ka value is 2. W gram of the acid dissolved in 30 gram of benzene shows a depression in the freezing point equal to 2 Kelvin. So delta TF is equal to 2 Kelvin. Now, when benzoic acid, this is benzoic acid. So number of moles of solute, which is benzoic acid, which is benzoic acid, it is equal to W upon 122. Okay. Now dissolved in 30 gram of benzene, so mass of solvent is 30 gram. If the percentage association of the acid to form dimer in the solution is 80, yani beta is 80 by 100, which is equal to 0.8. Fine. So what do you need to find out? You have to find out the value of W, है ना? You have to find out the value of W. So first, तो I is 1 minus beta plus beta by n, bete. So from that you can calculate the value of I. So once you calculate, you get value of I equal to 0.6. Right. Up now you have to put delta TF is equal to I into KF into molality. So delta TF is 2, I is 0.6, KF value is 5, and molality is what? Given mass, or sorry, number of moles into molar mass. Molar mass 30 into 1000. Now from here you can find out the value of W, which is equal to 2.44 gram. Okay. So answer is option number 1. Answer is option number 1. Now let's solve another question. How much amount of NaCl should be added to 600 gram of water to decrease the freezing point of water to minus 0.2 degrees Celsius? It means delta TF you have to take 0.2, right? NaCl I into KF into M. I का value you have to take 2 because NaCl dissociates into Na plus and Cl minus. KF का value you have to take 2. It is given. And molality, how much amount of NaCl? So mass of NaCl divided by molar mass of NaCl, which is 58.5. Molar mass NaCl 23 plus 35.5, which is equal to 58.5 into mass of solvent 600 into 1000. So from here you can find out W, which is 1.755, right? So that is the answer. Okay. Clear? Now let's do next question. The osmotic pressure of a dilute solution of an ionic compound XY in water. Okay. We have XY and its osmotic pressure is 4 times the to depth of a solution 0.01 molar BaCl2 in water. So this is BaCl2. So 4 times of this. Fine. Assuming complete dissociation. So what is pi? That is I1 into C1 into R into T, and this is 4 into I2 into C2 into R into T. RT cancel out. I1 is going to be 2 into C1. It is equal to 4. Here I2 value is Ba2 plus and 2Cl minus. So I value is 3 upon 1. So 3 and C2 is 0.01, 10 to the power minus 2. So you have to find out C1 value. So which is going to be 6 into 10 to the power minus 2. So answer is 2. Okay. Now let's do next question. Molar depression constant for a solvent is 4 Kelvin kilogram per mole. Molar depression constant yani Kf is 4. Depression and freezing point we have to calculate for 0.03 mole per kg. Molality is 0.03 mole per kg. For what? K2SO4. It dissociates into 2K plus and SO4 2 minus. So I ka value is 2 plus 1 divided by 1, which is 3. Okay. So delta TF is equal to I into KF into molality bete. So delta TF we have to find out. I is 3, this is 4 and molality 0.03. So when you solve this, you get answer equal to 0.36 Kelvin. Option 4 is the correct answer. Okay. Okay. Now let's solve next question. Next question says if 250 centimeter cube of an aqueous solution containing 0.73 gram of a protein A. So here we have protein A, 0.73 gram is isotonic. It means pi A is equal to pi B. So here we have protein B and which is 1.65 gram. Here 250 ml and here we have 1 liter. Fine, isotonic. So the ratio of molecular mass A, Ma and upon Mb we have to find out. So how to solve this? See, pi A is equal to pi B. It means Ia into Ca into RT is equal to IB into CB into RT. RT cancel out. So here we are not going to consider Ia. No consideration for Ia because protein does not dissociate. Okay, so Ca is what? Ca is what? Given mass of A, molar mass of A into volume. Volume is 250 ml, so into 1000 is equal to given mass of B, molar mass of B into 1 liter. So this is going to be this one. So WA is 0.73. Okay. So into 4 is equal to WB upon WB is 1.65. 1.65 upon MB and MA. So we have to find out what? MA upon MB ratio, which is equal to 0.73 into 4 upon 1.65. On solving this, we get 1.769. Okay. And we have to report in terms of 10 to the power minus 2. So 1.769 we can write as 176.9 into 10 to the power minus 2. So to the nearest integer, we are going to report answer as 177. Okay, answer is going to be 177. Okay, bete. Now let's do next question. Question says it's a theoretical question and that is based on different aspect. The size of a raw mango shrinks to a much smaller. Raw mango, it shrinks. Why? When you put this in the concentrated solution. Actually, what happens? Osmosis happens. Why? What is osmosis? flow of solvent from higher concentration to a lower concentration. So in raw mango we have more solvent concentration, and in this concentrated solution we have less solvent concentration, due to which raw mango shrinks. So answer is 1, that is the osmosis. Okay. Now let's do the next question. The elevation of boiling point, right? The elevation of boiling point of 0.10 molar aqueous solution CrCl3.xH3 solution is 2 times that of this. Okay, we have CrCl3.xNH3 and we have CaCl2. So this is 0.10 molar and this is 0.05 molar, and delta TB1 is actually 2 times of delta TB2. Fine. Okay. So now what we are going to do, we are going to write two equation and we have to find out the value of x. We have to assume 100% association. So see how to find out. Delta TB1 is equal to I1 into KB into molality 0.1. Delta TB1 I can write as 2 delta TB2 is equal to I1 into KB into 0.1. So delta TB2 is equal to I1 into KB into 0.05. This is first equation. Now we can also write from this delta TB2 is equal to I2 into KB into 0.05. So on comparing equation 1 and 2, if you compare equation 1 with equation 2, so I1 value is equal to I2. On comparing equation 1 with equation 2, I1 value is equal to I2. Now I2, how to find out the value of I2 bete? So see I2, Ca2 plus and 2Cl minus. So we get 3 ions na. So I ka value is 3. So here that is equal to 3. Right. Now if it is equal to 3, so we have CrCl3.xNH3. So in order to get 3 ions, so we should be having CrNH3 5, Cl2 and then Cl. Not Cl and Cl2. And question also says ki coordination number is 6. So it means we should be having 6 ligands over here, because now it dissociates into CrNH3 5 Cl plus 2 Cl minus. Then we get I ka value as 3, right? So value of x is equal to 5. Value of x is equal to 5. Got it? That's it. Now we are moving to our last type. Here we are going to discuss miscellaneous question. So miscellaneous question means we are going to apply different concept to solve the question, right? So let's see. So first question is list 1, Vant-hoff factor, right? Vant-hoff factor. So Vant-hoff factor is what? We can match Vant-hoff factor with third, normal molar mass divided by abnormal molar mass. Then B, Kf is cryoscopic constant, so B can be matched with first. C, solution with same as osmotic pressure, so that can be matched with second, isotonic solution. And D, azeotrope, solutions with same composition of vapor above it, right? So these are azeotropes, so this can be matched with fourth. On the basis of that, we can take the A as the correct option. Okay. Now let's do next question. Next question says the total pressure of a mixture of non-reacting gases X, right? So we have X and Y. So mass is 0.6 gram and here mass is 0.45 gram. Okay, bete. Molar mass is 20 and here molar mass is 45. So it means number of moles is 0.6 upon 20, which is 0.03 mole, and here number of moles is 0.45 upon 45, which is equal to 0.01 mole. Okay, so we have to find out partial pressure of gas X. So partial pressure of gas X is mole fraction of X into total pressure. So mole fraction of X, number of moles of X divided by total moles into total pressure is given 740. So number of moles of X is 0.03, total moles 0.03 plus 0.01 beta into 740, which we can write as 3 by 4 into 740, which is equal to 555. So answer is 555. Easy. Now let's do next question. Next question says the elevation in boiling point, right? Temperature of water will be same for 0.1 molar NaCl and 0.1 molar urea. No, because in NaCl dissociation happens and I का value we are going to introduce, which is 2, and urea no dissociation, so I का value नहीं होगा. We are not going to introduce I का values as no dissociation. So no I, right? So we cannot say this. Second, azeotropic mixture boil without change in their composition. This is true. This is true. Osmosis always takes from hypertonic to hypertonic. No. Hypertonic means less solvent concentration. Osmosis is the flow of the solvent molecules from higher concentration to the lower concentration. So this is not true. Next, let's see DE first. Then later on we are going to do D, right? We will see D. So E, a negatively charged sol is obtained when Ki solution is added to silver nitrate. So see, AgNO3, when I add AgNO3, so we get AgI plus NaNO3, right? Okay, and now what happened here? AgI adsorbed with Ag plus, right? Ag plus is adsorbed on AgI, right? Is obtained when Ki solution is added to silver nitrate solution, because silver nitrate we have more na, so we have more of Ag plus, right? So AgI, we have AgI and it is adsorbed by Ag plus. Okay, Ag plus is adsorbed on AgI, so we get positively charged sol. Positively charged sol. So E part is also false. Now let's say D part. D part says the density of 32% H2SO4. 32% H2SO4 means 32 gram H2SO4 in 100 gram solution. 100 gram solution. Having molarity 4.09 molar is approximately 1.26 gram ml. So density, it is given 1.26 gram per ml. We have to prove. So either we are going to take density and we can prove molarity is 4.09, or we can take molarity and prove density should be 1.26. So I am taking density. So see, 100 gram solution, so 100 gram solution, the density is mass upon volume. So volume is equal to mass upon density, which is 100 upon 1.26 ml. Okay. Molar mass of H2SO4 is 98 gram. Now molarity is number of moles, which is 32 upon 98. That is number of moles into volume, 100 into 1.26 but ml. So it means we are going to multiply numerator by 1000. So when you solve this, you get 4.1 molar only. 4.1 molar. So this is also 4.1 na. So it means this is true. So answer is option number 4th, B and D. Okay. Now let's do next question. The decreasing order of electrical conductivity of the following aqueous solution. See, electrical conductivity, it is directly proportional to number of ions. So if we have formic acid HCOH, we have acetic acid CH3COH, and we have benzoic acid COH. So the point is it dissociates into HC double bond O minus H plus. This dissociates into CH3 C double bond O minus H plus, and this dissociate into C double bond O minus and H plus. ठीक है बेटे? Let me write benzoic acid like this. So we get benzoate C double bond O minus and H plus. The point is which one is more stable. So see, here we have negative charge, right? So this H there is no inductive effect, nothing. So it is more stable. So first of all, formic acid. Now here CH3 is the electron releasing group, and here also we have electron releasing group, right? But the point is here we have hyperconjugated structure and here we have resonating structures. So resonating structures are more stable. So what we can say that this is more stabilized, resonance stabilized, right? In comparison to this one. So we have benzoic acid and then we have acetic acid. So answer is A, C and P. Okay, bete? Clear? ठीक है? A, C and P. Now, let's discuss this thing. X melts at low temperature and is a bad conductor of electricity in both liquid and solid state. So it must be carbon tetrachloride. Non-polar, it is non-polar. Silicon carbide, semiconductor. Zinc sulfide, semiconductor, right? Mercury is conductor in liquid state. ठीक है? So answer is fourth. Answer is fourth. That's it. All the questions are over. I hope you understood all the questions very well. I hope you like the video. If you like the video, then you can drop a comment. You can also join the PracBee Revision Program, which is a 10-week course. All the details are in the description box. You can also connect with us by writing a comment. Okay, then see you in the next video, and we are going to discuss coordination compounds in the next video. Okay, bye. Take care.